Hi everybody, this lesson is about rotational kinetic energy. So just like how all moving objects have kinetic energy, all spinning or rotating objects have what's called rotational kinetic energy. So the sort of energy a Ferris wheel would have or a merry-go-round, because they're spinning, would be rotational kinetic energy. Okay, so just like how linear kinetic energy is given by half mv squared, we use the rotational equivalence to get the formula for rotational kinetic energy. So the formula for rotational kinetic energy is half, and the rotational equivalent of mass is rotational inertia, and the rotational equivalent for velocity is angular velocity. So there's your formula for rotational kinetic energy, and because it's energy, no matter what form of energy it is measured in joules. Okay, now the thing is, we're coming on to some concepts to do with rotational kinetic energy. So spinning objects, so if you've got this and the only thing it's doing is spinning, just going around, so the only sort of energy it'll have is rotational kinetic energy. But however, if you roll an object, so I'm trying to show rolling an object, it's doing two things. It's spinning as well as translating, so it's going forwards as well as going around as it's going forwards. So it actually has two forms of kinetic energy. It's got linear kinetic energy as well as rotational kinetic energy. Okay, so if you're rolling something down slopes, the one that comes forward first or reaches the bottom first would be the one that's translating the most. It'll be the one with the bigger proportion of linear kinetic energy. Okay, and so something at the top of a slope. So if you've got a slope and you've got like all sorts of objects over there at the top of the slope, they will all, and if they have the same mass, they will all have the same proportion of gravitational potential energy, where m, g, and h is that height. And when they roll down, their gravitational potential energy has been converted to two forms. It's been converted to both linear kinetic energy as well as rotational kinetic energy. And the one with the greater proportion of linear kinetic energy will be the one that reaches the bottom first. Okay, so bye for now.